So now that we're done with some system I/O and variables, we can start getting in the real interesting part of programming, making our code actually do something. While yes, you can say what we've done already, our code was doing something, it wasn't really doing anything interesting. It wasn't making decisions. It wasn't doing the things that make technology so powerful. So that's what we're going to focus on in this video. So let's start this video by doing something a little bit simple. So I'm going to create an input variable, and I'm just going to initialize it to 1 for now. Eventually we'll get to the point where we're accepting user input and doing something with it, but for now, let's just say it's 1. A conditional statement is something that we can use to separate our code. So let's say I have something like this, where I'm going to say input is equal to 1. And then I have console.writeLine, input is not equal to 1. So when I run this code, it's going to do exactly what you expect. It's going to say input is equal to 1, input is not equal to 1. This is not okay. It has to be one or the other. Using a conditional statement is how we kind of break this up. So the most basic conditional statement is the if statement. So if, and then after if it wants parentheses. Inside the parentheses is what we call a Boolean expression. The expression inside these parentheses has to equate to either true or false, nothing else. And the way we can do that is through the comparison operator. So the comparison operator is 2 equal signs. That's a little weird. Generally you say if something is equal to something, it's just 1 equal sign. In computer science, 2 equal signs is comparing the objects. 1 equal sign is setting it. You can see that right here. So 1 equal sign, I'm saying input equals 1. With 2 of these, I'm saying, is the left side equal to the right side? If so, we are true. If not, we're false. So let's go ahead and say if input equals 1. Now notice how I said equals there when in reality it's equals equals. This is one of those weird English is a weird language kind of things where this means equals, this also means equal. Are they equal or am I setting it to be equal? Something like that. But now also notice how I put these curly braces under here. So these curly braces signify that if this is true, so if input equals 1, I want to run whatever code is inside of this. So naturally, I want to do this. So if we run our code now, we can see, well, we get the same exact problem. Input is equal to 1, input is not equal to 1. That's because as soon as it gets out of this statement right here, as soon as it says, is this true, write this, it just continues what's next. It just continues reading the rest of the code. But let's ignore that for now, and we're going to try something different. So for now, I'm going to change input to the value of 2. So based on our logical reasoning, we should be able to say, this will not pass, this will not work. So this line should not print. So let's give it a try. Bingo. So input is equal to 2. Is input equal to 1? No, it's not. So we're just going to completely skip this code. Anything in between these curly braces is not going to run unless this is true, which allows us to really branch off and do many different things with our code. So let's take a look back at our original problem. When we have input equal to 1, when we call this code, it runs, it does exactly what it should do. It runs this bit of code, but it continues to run this. Now, what we can do here is an additional conditional statement. Now, we could do something like this. If I could spell. This right here would give us the desired results. Now, in computer science, an exclamation point generally means not. So if a Boolean property is true and you put an exclamation point in front of it, it means the opposite. If it's false, it again means the opposite. So what this is saying is input is not equal to 1. This right here will do exactly what we want it to do. However, why this is the kind of conditional statement where if we run one of them, so if we run once, we know that nothing else is going to run. This is a very true or false statement. It's not an open-ended statement in a sense that if input is 1, it is going to say it's 1. If it's not 1, it's going to say it's not equal to 1. So this works if I run it. you will see that our input says input is equal to 1. Perfect. But again, we have these two if statements here that are kind of, they're separated when in reality they belong together. So the way to do this is through the use of an else if statement. Now, something interesting about an else if statement is you can't just have an else if statement. An else if must follow the closing curly brace after an if statement or another else if. Period. It can't go anywhere else. So let's go ahead and run it. So we still get the same results. We still have the same results from our code, but it's a little bit more efficient. If this runs, it's not even going to bother checking this because of this else here. It's going to see this and it's going to be like, oh, okay, well we ran this, so no reason to check this. For example, let's go ahead and put this here. So in reality, this is true. This is also true. However, because this has already run, this one will not pass. So when I run it, the input is equal to 1. So we get this line of code to print out. We don't get this line of code to print out. So pretty straightforward, simple. Let's take it back to how it was before and do the same thing. These are actually going to run both of them. This is why an else if statement is so useful sometimes. Granted, these are completely different things right now, and this is kind of a error at this point. But the else if kind of short circuits. If you have, an if, else if, else if, else if, else if, else if, it'll only check the first one that it needs to as soon as it passes. It won't bother calculating the rest of the code. So let's kind of extend this a little bit. Instead of saying, input is not equal to 1, let's say input is less than 1. And similarly, 1. So let's do this. And I need to change this to less than. So this right here is a good example of what I'm trying to do. If the input is 1, I'm going to say the input is 1. Otherwise, if the input is less than 1, print this. Otherwise, it's this. So we're going in a very linear kind of pattern here. But in reality, because this is an if, else if, else if, no matter what is in these parentheses, only one of these blocks of code, when I say a block of code, I mean something between two curly braces, only one of these blocks of code is ever going to run. So let's take what we've done here and make our code a little bit more interesting. So instead of me just, putting a value here, let's take in user input. So I'm going to not initialize input. I'm going to come down here and I'm going to say console.writeLine, please enter an integer value. And better yet, I want it on the same line, so I'm going to write, and then at the bottom here, I'm going to do console.writeLine. But here, I'm going to say input equals int.parse, and we saw this in the first video, console.readLine. So I'm going to get the input from the user. So I'm the user, I'm going to input, let's say 5. It's going to take this as a string, because remember, readLine returns a string. You can see it in that darker blue text there. The far left value is the return type. So it's going to return a string. Whatever I input, it's going to take as a string. Parse, however, takes a string and parses out to an integer. You can see the string s there. That is the parameter for this, or the argument for this method. And then the int, the far left int, is the return type. So we're going to take it and we're going to store our input in input. And then we're going to write a line just to put us on the next line so that we don't have to worry about, putting two things on the same line and it'll look clunky. So now we can do a lot more interesting stuff. So I'm going to run the code and it's going to ask me for a value. So I'm going to say 24. Input is greater than 1. Okay, this is cool. Input, that's cool and whatnot. But what if I want to actually print the value that I input? Well, remember we talked about string concatenation a few videos ago. So let's come down here. And instead of doing input, I'm going to say, input, but I'm actually going to use the variable. Also, notice how I put a space here. A common mistake a lot of entry-level programmers do is they don't put a space here. They say input is less than 1. But if you think about it, I'm taking input, which is 24, for example, and putting it right next to is, so there's going to be no space there. You need to manually put the space there yourself so that it looks attractive. So let's do the same down here for for greater than, and then, you know, if input is equal to 1, we don't need to replace this. This can stay as is. We're saying input is equal to 1. We don't need to say 1 is equal to 1. That's obvious. So let's go ahead and run it again. Enter an integer value. Let's do 42 this time. 42 is greater than 1. Cool. And then I press any key, close the program. Run it again. Let's test less than 1. So I'm going to put negative 412. Negative 412 is less than 1. And then just to, you know, provide sanity, checking our edge cases, 1. Input is equal to 1. So right now we have written a very, very, very simple program that takes in user input, does something based on that input. All this does is print out to the user, and it skips the rest. It only does something specific. It skips some of your code. A lot of people think, you know, code just goes line by line by line. While it does that, you can make it skip certain pieces of code that you don't want to run. So with what we have now, let's go ahead and just comment it all out for now, just to do something else. And let's try something a little different. So I'm going to ask the user question. I'm going to say, hi user, are you older than the age of 16? And I'm going to preface, you know, it's always good to let our user know what they should input. Yes or no. I actually like slash better. There we go. Yes or no. Cool. So I'm going to keep this on a right line now just to keep it simple. I'm going to then create a string called sinput for string input equals console.readLine. So now this string right here is going to be yes or no, hopefully. You know, we don't really have any sanity checks in here to say, is our user listening to instructions? But let's go ahead and assume that they are. So to make this more interesting, we're going to say if sinput is equal to yes. So if they've entered the yes input, we're going to say, oops, console.writeLine. Cool. Go get your driver's license. Cool. If they're older than 18 or older than 16, we're going to say go get your driver's license. Now let's handle the no response. Darn, you can't get your license yet. Very simple, you know, if input is this, do this. If input is this, do otherwise, if input is this, do this. So let's go ahead and run this. So, hi user, are you older than the age of 16? I am, so I'm going to say yes. It says, cool, go get your driver's license. Well, I have my driver's license, so I don't need to go get it, but the point is it works. So let's sanity check. Let's try another one. Let's say N. Darn, you can't get your license yet. Unfortunate. Well, let's try this, okay? So in our previous example, any integer input fit one of these bills, no matter what. But what happens if I put something in here that isn't yes or no? What if I put gibberish? It's not going to do anything. It's literally just going to skip this code right here, which is exactly what my code is telling it to do. So let's close this. Let's use another example. What if I say capital Y? Uh-oh. There's a problem there. What if I type yes? Uh-oh. We still don't get a response. So by writing our code this way, it works if we have absolute perfect input from the user. Now, you know, taking a Y and a capital Y is reasonable for this situation. So let's go ahead and do something like this. And let's go ahead and do something like this as well. Oops, I forgot an if there. And you know what? Just to drill the point in. Oops. Let's do that. So we have 1, 2, 3, 4 situations now that will catch a reasonable input for the user to type in when it comes to, are you older than the age of 16? Yes or no. Now, I could go do this for all the no's. I'm not going to. That'd be a waste of time because I'm going to show you a trick here in a minute. So we're going to run our code again. We're going to say yes. It's going to say, cool, go get your driver's license. We're going to say yes with a capital. It's going to tell us to go get our driver's license. We're going to say just capital Y. It's going to tell us to get our license. So it works in a sense that it does exactly what we want it to do. But this is a whole lot of code for effectively one thing. You know what I'm saying? This is one simple thing. Let's simplify it. So in programming, we have what's called conditional operators. And these conditional operators are or. So this right here is the or operator. It's two bars next to each other. That is the shift and the key above the enter button. That'll make the bar on your computers. That's or. We also have and, which is shift 7, two ampersands. This is saying, Boolean statement 1, Boolean statement 2, are they together the same, something like that, or are they both true? That one. And then another one we're going to talk about, which is very rarely used, is the caret operator. So the caret operator is called the exclusive or either or. If one of them is true, great, no problem, let's just continue. Exclusive or says only one can be true. Only one of them has to be true. If two of them are true, the overall problem equates to false. But let's go ahead and use this to remedy our mess here, because this much code is a mess. So this right here I know is good code. It checks for a capital Y. So I'm going to cut that. I'm going to say or here. So I can just completely eliminate that problem. So if I'm saying if the input is equal to lowercase y or the input is equal to uppercase Y, then cool, go get your license. And we can do the same thing with these below us. This code is much more readable, much more understandable than what it was before. If the input is lowercase y, or the input is uppercase Y, or the input is just yes, or the input is yes with a capital Y. This is super nice and easy, but let's try something else. I type relatively fast, and oftentimes if I go to type yes, I might get something like this. Capital Y, capital S. It still fails. We really want to write good code. We want to write code that encapsulates every problem and fixes every problem. We could have it to where if none of this, or if they did not input a valid option, it would print something else. So let's demonstrate that real quick. So if else if, pretty straightforward. Now we're gonna continue talking about it. But let's go ahead and skip to the third part of the if else if tree. The last one is else. So if this or if this, if none of these are true, we're going to do this code. So I'm going to say console.writeLine, your input was invalid. Okay, so we're going to actually warn the user that their input was bad. So are you older than the age of 16? I'm going to say capital E, S, your input was invalid. Perfectly reasonable. This is a good situation to use an else, but we'll talk more about this in a minute. But we still have in our yes check here, if yes, we still have a whole bunch of stuff here. This is 1, 2, 3, 4 things that we need to check. If we want it to be perfectly, encapsulative and encapsulate everything, it'd be S input equals YES, things like this. We'd have to check a whole bunch of stuff. This is a problem. We don't want to have to check all this. So we're actually going to simplify it just down to these two. But I'm going to show you guys a cool trick. If you remember from our variable video, a string variable is essentially an array of characters. Now we'll be getting into arrays here in a few videos, but I want to show you. I want to give you a little preemptive view of what it looks like. The way you index arrays is through curly braces. Square brackets. So with my square brackets like this, I'm saying I want the first. Now you're sitting here, hey Ryan, why are you saying first? You put a 0 in there. In computer science, we count a little weird. We don't count 1, 2, 3, 4, 5, 6. We count 0, 1, 2, 3, 4, 5. Everything starts at 0. We never start counting at 1. So in this scenario, I'm saying I want the first character of my input, which is yes or no. Whether it be yes, yes, capitals, lowercase, whatever it be. So we're saying if the first one equals this, but it's giving me an error. It says operator equal equal, the comparison operator, cannot be applied to operands of type character and string. When you put these quotation marks around anything, it's signifying that that is a string. But if you remember from our variables video, if I put apostrophes here, we are now saying it's a character. So this one works, this one no longer works, but I can fix this by going like this. So I'm now saying if the first character of our input is a yes, print this line of code. Or I said is a yes, I mean is a y. Whether it be a lowercase y or an uppercase y. This handles every single spelling of yes. I can't really think of it, but think of another language where yes is 15 characters long. If you wanted to encapsulate every type of spelling of that word, your or statements here would just be massive. There'd be a bunch of them. Whereas if you just look at the first letter, you're good to go. That's generally a safe bet. So let's do the same thing down here for our no category. And by default, or by habit, I did that, but I want that. So now this is going to work just as we expect. So it's going to say, hi, user, are you older than the age of 16? I'm going to say, yes, all caps. Cool, we haven't handled that yet. It's still going to handle it. It's going to look at the first character, realize it's a Y, and it's going to be cool. Go get your driver's license. Similarly, let's try no. Let's say I fat finger N O P. P is right next to the O, so I accidentally hit it. We're still going to run it. We're still going to get the correct result because the only thing it cares about is the first letter, the first thing at the beginning. So using what we know from this point, let's act like a real programmer now. Let's say we have a real problem to solve. So we're going to have a int x position, and we're going to initialize it to, let's say, 5. Imagine we're making a game like Super Mario Bros. We're going to start at the 5 unit position. He starts mostly on the left side of the map. Imagine like all the way to the left is 0. And imagine the goalpost is at 100. Let's say something like that. We can assume we're starting at x position 5. So I'm going to say if x position is greater than 0, because remember, 0 is our far, far left side, and x position is less than 100. 100 is the goalpost. We want to do something. We want to, run character controls. Allow somebody to use our Mario character. So let's handle our other situations. The reason we put this in the if statement is because this is the most popular call. This is the one that's going to be called most often, so we should put it here first, because if it runs, it's not even going to bother checking the others. It's going to save processing power. But let's try the other ones. So else if x position is less than or equal to 0. So if we're trying to go left of the map, so if we're trying to go backwards in the game of Super Mario, we're going to run controls to kind of snap our character back to the 0 position. So we're going to say snap character back to x position 0. Okay, super simple. Another one is else if x position is greater than or equal to 100, run game winning situation. When you grab the flagpole, you slide down and you continue. Through the use of this, we're able to control the pace of the game, how Mario works. But specifically, we use the and here to say if it's between this and it's between this. Now, something that you might see sometimes, like as you go through the internet looking, asking questions, looking through problems, somebody might do something like this. So this code right here is going to do exactly the same thing as I had it before, but it's using what we called a nested if statement. Now, this is a little bit more expensive, and in this situation, I would not recommend doing it this way, but a nested if statement is oftentimes very, very useful. So let's find an example that we can show here. So I'm going to go ahead and revert this back to how it was because, in terms of programming, this is the more correct way to write it. This is a little bit more efficient. This runs faster, even though a very slight amount. It's still better to do it this way. So let's go ahead and comment this out, and let's create an example for nesting. So I'm going to create 3 prices, or item prices. So I'm going to say int item price 1 equals, let's say it's going to be $10. We're going to say int item price 2 equals, let's say, $13, and we're going to say int item price 3 equals $24. So we have 3 items here, but we also have a budget. So int budget. And let's say our budget is $23. We want to be able to find what things we can buy. So can we buy item 1? Can we buy item 2? Can we buy item 3? Can we buy all of them? So on and so forth. So we're going to say if budget is greater than or equal to item price 1, and just to make this simple, I'm going to rename these to a smaller name just to make it easier to type. Something cool, and again, this is the whole Visual Studio writing code for you kind of thing. If I click on this and press Control-RR, it'll let me rename it. Everywhere else in my code, this will be renamed. It's super, super cool. So item price 1, I'm going to say P1, P2, P3. So I'm going to say if budget is greater than or equal to P1 plus P2 plus P3. So if our budget is greater than all 3 prices put together, we're going to say you can buy every item. Otherwise, this is where we want to do some nesting. This is where clean code will come into play. So if we could buy everything, cool. Otherwise, we want to just go into an else statement. Let's go ahead and add up some budgets. So we're going to say if budget is greater than or equal to P1 plus P2, we're going to say console.writeLine, you can buy the first 2 items. Now, here you might be thinking that we say else if, but what if I want to know, what if I can buy P1 and P2? What if I can buy P1 and P3? What if my budget is relatively large for that? In our given example, it won't be, but we'll mess with that here in a minute. So we're going to use another if statement. We want both of these ifs to run in this given scenario. We want to determine what are the valid options, what are the things we can buy. So I'm going to say budget greater than or equal to P2 plus P3. And then I'm going to copy this to make a time saver. You buy the last 2 items. And then we're going to do a mix. So we're going to say if budget is greater than or equal to P1 plus P3. You buy the first and the last item. Okay, so in this code, we are running this situation. So this is a terrible example because we can't buy all 3 of them, and we can only run one of these. So let's kind of alter our prices a little bit. Let's change our budget to this, and let's change this to 12. Oops, so 12. So we're going to run our code, and it is going to print out, oops, you could buy the first 2 items, you could buy the first and the last item. We can't, however, buy 2 and 3. Notice how it didn't say this. That's because P2 plus P3 is equal to 25. 25 is greater than 23, so we can't, it doesn't run this code. We can't purchase those items. So this is where programming is going to get a little bit complicated and a little bit more interesting. So right now, we put an if with an else on it. The if says, if we can buy all 3, we can buy every item. There's no reason to try to, break it apart, no reason to do any extra code. We could just say you could buy all three. If they want to buy the first and the second, they could buy it. If they want to buy the second and the third, they could buy it. If they want to buy one individual item, they can buy it. And then our else handles other situations. So specifically, our else right here handles item 1 and 2, item 2 and 3, and item 1 and 3, which we all print out to the user saying you can buy, this mix and match of items. But what happens if in this situation, let's say they couldn't buy 2 items. Let's say they only had enough money to buy 1 item. How do we check that? Do we just put, if, budget is greater than P1 here? We could do that, but then it's going to come down to the same example we had before where it's going to say, oh, you can buy the first 2 items, and then it's going to come down here and it's going to say, oh, you can also buy the first item. Great, you already told me I could buy the first item and the second item. Why are you telling me I could buy the first item again? It was implicitly implied that I could buy the first item when you said this line of code right here. So instead of doing this, we're going to add some logic to our code. So we're going to create a Boolean variable called can buy 2 items. And we're going to default it to false. Again, this is where code gets a little bit complicated, so try to pay attention. Try to think about why I'm doing this, what's going on, and I'll help explain it afterwards. So we're going to initialize can buy 2 items to false. The moment one of these run, I'm going to say, okay, if one of these runs, it means the user can buy 2 items. So I'm going to say can buy 2 items equals true. I'm going to set the value of my Boolean to true. And I'm going to do that in all of these. Okay, so now when we come down here, remember, so this code runs. If this doesn't run, then it runs this. All of these are going to run together, or not together, but they're going to run sequentially, one after the other. If all of them are true, they're all true. Great. You can buy first and second, you can buy second and third, you can buy first and third. Great. Those are useful information for our user. However, down here, I'm going to say if can buy 2 items is true, then I can consider, is false. So if we determined we cannot buy 2 items, and the way we determine this is by defaulting this Boolean variable to false. If we come down here and say can buy 2 items equals false, then we want to go and determine can you buy the first item, can you buy the second item, can you buy the third item, which ones can you buy? So it's going to be very similar to this, so I'm just going to copy this down here. We're going to do P1, P2, P3. You can buy the first item, you can buy the second item, and you can buy the last item. So now, all of our code here should be pretty sound. Let's kind of play with these variables to see what we get. So the first one, we can buy 2 items. So notice how it says you could buy the first 2 items and the last 2 items. That's because our math, the way it lines up, is how we had it. It doesn't say, oh, you could buy, the first item, or you could buy the second item, or you could buy the third item. It's implicitly told to me that if I can buy the first 2 items, then I should be able to buy just the first item or just the second item. So let's change our values a little bit. Let's say our budget is, let's say it's just 15. So we have $15. So thankfully it's going to come in here and it's going to say we can buy 1 item. Whichever item we want, we can buy it, but we can only buy 1. Now let's come down here and say our budget is 12. We can no longer buy the second item. The second item is too expensive. So by adding, a little bit more complexity to this Boolean expression here, or this Boolean variable, we can do some interesting things. We can make it say certain things whereas it wouldn't say other things. Now, this is going to be it for this video. It's already running a little bit long, so I'm going to try to cut it off pretty quickly. I'm going to put some practice problems that you can do on Schoology that will help you get acclimated and think about how to use ifs, when to use ifs. I highly recommend you do this because you're going to need a lot of this kind of logic for the final assessment. So this video demonstrated conditional statements, and it's really where programming starts to become interesting. Our next video is about iterative statements using loops that allows our code to run the same thing multiple times. And you might be saying to yourself, why do I want to run the same thing multiple times? It sounds redundant. But as we go through that video, you'll start to see how all of these bits and pieces come together to make a really interesting project.